Hello everyone, welcome back to my YouTube channel. So on day 7 of Kubernetes series, today we are going to discuss about stateful sets. So let's understand first what is stateful set. So a stateful set is a special Kubernetes controller for managing stateful applications. Stateful applications like for your databases or your message queue services, any other storage services. So these are the stateful applications. Why? Because they store your data. So when we use a stateful set for those applications, Kubernetes ensure that each pod will have a unique and predictable name. It will keep its own persistent storage system, and it will start and stop in a particular or in a defined manner on a safe order basically. So our data will not be lost. So what happened in the case of stateful sets? Suppose if we are going to stop or we are going to delete our application, in that case whatever the data we have, like in the duration of start and stop or delete, basically whatever the data will be there, the first thing of a stateful set, it's first it will store that data in your persistent or in your storage systems. Then it will terminate the pod. It will not directly go and terminate the pod. First it will save the entire data, then it will go and terminate the pod. So this is the benefit of stateful set. Okay, now let's see why do we need a stateful sets. So not all applications are created equal. Like some applications will be, for example, stateless, like our web servers. So they don't need to remember anything. If one crashes, like if anything goes wrong with our web servers, Kubernetes will automatically replace it with another one, and nobody notices it. But others like stateful sets, like databases, queues, or storage systems are stateful. They need to store data that persistent even after restart, have a fixed name or identity for replication or client connection, start or stop in a specific order to stay consistent. That's why we need a stateful sets in our environment, because deployment is not enough. Deployment generally we use if we are going to deploy any stateless application. But in general, when we see in a real time or in real world, generally we deploy a combination, like it will be combination of stateless plus stateful sets. So like your web servers, and which will be connecting to your database servers. So that's how basically we deploy in real time scenario. So that's how we should be aware what is stateful sets and how we use it. Okay, let's understand the key features of stateful sets. So the very first is stable identity. So each pod gets a unique name, like my app01, my app1, my app2. Even if one pod crash and come back, it gets the same name. What does it mean? Suppose my app01 removed or deleted or maybe terminated or maybe crash. In that case, Kubernetes will try to create another new pod, and then the pod name will be myApp0 only. So this is the benefit of stateful sets. Stable storage. Each pods get its own dedicated disk, like persistent volume. So if a pod restart, it connect back to the same data. So suppose my app01 got crashed and Kubernetes created another new pod, the replacement pod with the same name, my app01. In that case, whatever the connection or whatever the volume was attached to this particular pod, with the volume with the same name, attached it back when the container will up and running. So this is the benefit. So for example here, my app01 is always gets pb-my-app-01. If we have mounted this pod with this volume, then this pod is always get when it's up, it will automatically attach to this persistent volume. So this is the benefit of stateful set. Graceful shutdowns. So when a pod is deleted, Kubernetes waits and ensure the app finishes its works, data is saved properly before removing it. So this is another benefit, graceful shutdowns. So in this case, we will not lost our any kind of data. So When should you use a stateful sets? So use case, if we are using any databases in Kubernetes, then we should use a stateful sets because we are going to store our data. Message queues like RabbitMQ or Kafka, in that case storage like Redis and Cassandra, in that case we have to use. So these are the use cases where you should create a stateful sets for these applications. So in our demonstration we are going to see a storage use cases with Redis. Now let's see a quick comparison between stateful sets versus deployment, because these are the two main which we generally use on day-to-day basis. So first we will see a pod identity. So in deployments, all pods are equal because we define a replica set. So deployments generally create an identical pod. But in the case of stateful sets, each pod has a name. So like we've seen my app01, my app1, my app2, like that. Persistent storage. In the case of deployment, it will be shared or stateless. But in the case of stateful set, the persistent volume will be dedicated per pod. Startup order, deployment will be in any order, but stateful sets one by one. So this is ordered basically. Use cases, deployment generally we use for web apps and APIs, and stateful sets generally we use for databases and queues. If your apps doesn't need a storage of fixed identity, stick with a deployment. It's a lighter and easier way to manage. But in real world, generally we use a combination, because anyways, like if we are using any e-commerce application, they all need a database because they need to store their data. So generally we will see in a real world a combination of stateless plus stateful sets, like web server plus databases. So same we are going to demonstrate in today's video as well. Okay, now let me move to a demonstration part. So I'll go to my GitHub repo. I have already created manifest files, and here we are going to use a custom Docker image. So for that, this is a simple Node.js applications. So if you want to do hands-on with your own in your own systems, you can simply use this particular part of code, and you can push a Docker image in your local system, or maybe in your local Docker account or Docker Hub, whatever you like. So this is the simple Node.js applications which basically connect to a Redis. So once this deployment of this application will be completed, and when we browse this application, we will get a message like something Redis, okay, Redis connected something. So we will see in a demonstration. Okay, so I already have a Docker image built, so I'm not going to create a new Docker image. So you can see there are 4 files basically: guestbook, frontend, deployment.ml, guestbook, frontend, service.ml. So these are the stateless application, or I would say frontend. So these two will be our stateless, because we are going to use your deployment and services to access our frontend. And for backend, we are going to use Redis headless service and Redis stateful ML file, basically stateful sets. So let's me quickly give an overview about all these 4 files basically. So Redis headless service ML file basically gives or provide a stable DNS name. Redis stateful sets deploy Redis with a persistent storage. So here we are getting basically a stable identity from this file headless, and from stateful sets basically we are getting a persistent volume, so we will not lose our data. And the guestbook frontend -service.ml file, it basically expose our guestbook frontend via node port IP, and if you want you can use a load balancer as well. Guestbook frontend deployment.ml file, this is to deploy our front-end application, so basically stateless. So guestbook are our stateless and Redis are our stateful sets. Now let's see a little more detail about all those files. So Redis headless -service.ml file will provide a stable Redis pod identity. So it's allow other pods to access Redis directly via DNS name. Why? Because statefuls require headless services to provide stable network identity. And then we have a Redis StatefulSets. So this is generally we are going to use for our persistent storage for our data. And this is the very simple. So like we are going to expose our front end, and here basically we are going to deploy our applications. And here we are going to use environment variable as well, because we have to specify something which basically allow to connect our front end to back end. So for that we are going to use an environment variable as well. Okay, now let me quickly show you the content of these files. So we'll start with Redis headless service first. So this is the simple service. This is the name of our service, which is Redis headless. Then and the labels, which is app Redis, and the specification, the port. This is the Redis port basically, and the name of the service, and cluster IP is equal to none. So if you make a cluster IP colon none, this make it's a headless. And selectors we are using app and Redis. So let me quickly open my Visual Studio Code. And before that, let me copy the name as well. Okay, sorry, let me move to this screen. Okay, so first we will create a file called Redis headless service.ml file, and let me copy the content of this file. Okay, now let me deploy this file, run this file. kubectl apply -f. Okay, so error validating. Okay, I think the Kubernetes cluster is not up and running, so let me start it. Okay, so now I have started my Kubernetes cluster. Now let me clear the screen and rerun it. Okay, so if I'll verify it, kubectl get services. So we can see our Redis headless services is deployed successfully, and we can see the cluster IP is none. So it means this is the headless service. Okay, now let me close this, and let me copy our another file, which is our Redis StatefulSets. This is a very big file. Let me explain you once. I'll create this file in Visual Studio Code. Okay, let me save it. Okay, so the API version will be app/v1. Kind is a StatefulSets, because we are going to create a StatefulSets. This is the name of our StatefulSets, which is Redis. And under specification you can see a service name, which is Redis -headless. This value, this name basically must match with the headless service which we have created. So if I go back to here, this is the name of our Redis headless service. So this name should match here. And replicas, so we are going to create a one instance of our Redis storage. And under selectors, okay, let me remove it. So under selectors, basically we are going to select the match labels, which is app:redis, and the same label we have defined here. So you can see the labels. So we are basically referencing it, StatefulSets with our headless services. And this is the general template here. So this is the our Redis pod template basically. So this is the template, metadata, labels, specification, containers, name, the image we are going to use, Redis latest image basically we are going to use, and these are the commands to start a Redis. And if I'll go to come to a port part, this is the container port. So this is the default Redis ports, which is 6379. And here we are going to use a volume mount where our data will be stored. So this is the name of our volume mount, which is Redis -data, and this is the mount path, which is /data. And again, this is the same which we already discussed, liveness probe and readiness probe. So this is a recommended and ideal, or I would say a best practices to use liveness and readiness probes in all your manifest files. And this is the volume claim template. So this is the name of metadata name, and the specification access mode. Here you can see read write once. So it means one pod at a time can write, and we are going to allow 1 GB persistent volume storage capacity. Now let me go and close this file and close this. So now let me create a Redis, let me deploy the Redis file. So kubectl apply -f. Okay, so if I search here kubectl get pods, so you can see we are getting a StatefulSets pod, which is Redis -01. So this is the unique name, basically the, I would say, fixed name for this particular part. If we will define 2 replicas, then the name will be Redis -2. So let's verify if it's created. Okay, so now the Redis pod is up and running. So we have already set up a backend part or StatefulSet parts. Now we need to set up a stateless parts, because from the stateless we will connect to our Redis system or Redis database. So let me close the screen, sorry, clear the screen, and let me go back to my file. So here we'll go with Guestboot front end service. So let me copy the name. And this is the node port service, basically, which we are going to create. And again, these names, these labels we have defined in the deployment.ml files. That's why we are referencing. And this is the node port. On this port we will be able to access our application. So let me save it and run it. Okay, so if I'll verify kubectl get services, so now we will see 2 services, one for front end and one is headless service for Redis. Now let me clear the screen and let's create a final manifest file, which is guestbook frontend deployment.ml file. So here basically we are going to describe, okay, we need to connect to this particular storage system. Oh, sorry, let me create the file first. Okay, so if you see till here, everything is remain same, apart from we are using a custom image which we have created from the Docker file. So the image name is mynode js-app:101, and this is in my local account. Okay, so this is the interesting part here. So from the environment variables, we are given a name and value, key value pairs, basically to connect directly to the Redis pod. So because this is the headless service. So when we use when we use our front end and back end together, we need to connect to a database. So in that case, we can use environment variables, or maybe secrets also you can use. And so on this host, basically it will connect on this port. So this is the detail of Redis part. So now let me save it, and rest all the things, all the files are same. So instead of 2 replicas, let me create 1 replica first. Okay, so now let me run it, then it will be more clear. kubectl apply -f. Okay, kubectl get pods. So it will take couple of minutes. Okay, it's up and running. So now we have 2 pod running. one for front end and one for back end, which is Redis -01. Now we have opened our front end at if I'll go to service 30120 port. So let me copy this, and if I'll type here localhost colon, okay, so cannot get, we are getting some response. It means we are connected to a Redis. So to verify it, we will use health chat path basically. So we get a response, okay, Redis connected. Now next thing what we need to verify, we will store or we will add some data on this file. So for example, the Node.js application just simply print our items basically. So if I'll copy this and if I'll search here items, so there are no items as of now. You can see there are no items. So what we will do, we will add few items inside our Redis cache. So for that we will use a Postman. So let me open a Postman client. So till now basically we are connected with Redis cache or Redis storage. Now we need to verify the persistent volume thing. So before that, okay, let me move it here. So this is our Postman client. Let me maximize it. So here what we are going to post few items on this particular URL, which is our front end URL. So from front end we are adding data in a backend. So if I'll come to a body part, so for example, let me sample one and let me send it. So here added sample one item one. So if I will refresh my application, so you can see here we are getting simple item one. So if I'll simply here change item 2 and let me send it. So now we have added 2 items in our Redis storage system. Now we need to verify if I will delete my pod. In that case, still we, like when we create as soon as we delete our pod, Kubernetes will try to create a new pod. So we need to verify if the pod is getting to attach with same Redis storage or the same persistent volume or not. And also we will see a persistent volume kubectl get pvc, sorry, it's pvc. So this is the name of our persistent volume claim. Okay, so let me go back to my GitHub repo once. If I'll go to there is a 2 readme files. So one is for simple introductions and another is for demonstration as well. So here if I'm just thinking if I have missed something. I don't think so, so it's fine. Okay, so now let me go back to our terminal. Now what we will do, kubectl get pods. So we will get this pod, the starting is 57f. So now what I will do, I will delete this pod. Okay, it's taking some time. Let's rerun it. So still we are able to see, it means it's already created a pod already. So if I'll check kubectl get pods, So okay, so the name, okay, so you can see the previous name was in the last digit, if you see JADVWTK, which we have deleted, and it is created a new pod with the name of SQNFR. So this is the new pod basically. And if I'll go back and refresh it, maybe let me close it. So still we are able to see the data, because as soon as Kubernetes created a new pod for us, it will automatically connect it to this particular Redis storage. And if we will refresh this one as well, so we are getting okay, Redis connected. It means the stateless and stateful sets are working fine. Okay, so if you need to verify the mounting path as well, like this particular pod is connected to which mounting path, so for that basically what we will do, let me copy the pod name and let me clear the screen. kubectl describe pod and pod name. So here we will get lot of details about pod as well. So if I'll go to a volume sections, okay, not volume sections, maybe so you can see the environment is Redis 0 hyphen Redis headless service, it's connected. So we need to find, okay, name space, okay, this is fine, mount path. Okay, so this is something different. Okay, actually we are looking for guest book front end. No, actually I was looking in a wrong pod. Let me clear the screen. So we need to look for Redis pod, kubectl get pods. So actually we need to look on Redis -0 pod. I was looking in the wrong place. So kubectl describe pod and pod name. So here we can see under volumes, type is persistent volume claim. This is the claim name. And if I'll go here mount path, so slash data from the Redis data. So this is the read write ones which we have specified. So if I'll quickly go to StatefulSets, so you can see the volume mount we have specified slash data. So whatever the data we have stored, that will be inside a slash data directory. So if you want to check the data as well, for that basically you have to go inside the pod. So that is again a lengthy process. If you want, we can go to a pod as well. Let me go and quickly check on the pod as well. So let me clear the screen. We will type kubectl get pods -l app equal to Redis. Okay, sorry, actually, as we know the pod name, which is Redis -01. Okay, so I will run command kubectl excc-it and the pod name, which is Redis -0, and we will type --sh. Okay, so we are not able to use --sh command here. Let me type search for bash. Okay, so bash. Let me clear the screen. Let me rerun it. Okay, so now we are inside the pod. So now if I'll do here ls/data, so we can see this append don light dir. So this is the basic. If you are able to see this particular part, it means you are its mounting is correct, like it is mounted successfully. So if I'll go to inside this directory, let's see if it's allowing. Okay, let me do one thing, ls-l. So we will see total how many items we have. So total 4. And if I'll search for ls-al, okay. So it means like if you if I go to, so you can see here append only, this is something that Redis use the A of basically. So this is the A of persistent storage volume. So if we are able to see this message, it means the mounting is successful. And if we will run here a cat command as well, so if I'll let me search here cat /proc/mount. So we can see lot of data here. This is the container data basically. So it means the mounting is successful, but there are a lot of things which we can verify inside the pod as well. So that is not something which we are going to see. So you can see here the dev /data as well. So and read write once. So this is where our data is available. So that's all for today, I think. So I just want to showcase how we use stateless with stateful sets. So here basically we have seen a combination of front end and back end, and we have also seen how stateful sets works. So if you are going to delete your front end, and Kubernetes will try to recreate your pod, and it will automatically attach to the existing or the previous volume mount or previous persistent volume claim which it was attached previously. So that's all for today. See you next video. Thank you so much.